Next are the helper T cells. The helper T cells are distinct in that they not only moderate adaptive immune responses, but also innate immune responses. It's like killing two birds with one stone, kind of, or something. These cells have no cytotoxins and do not directly kill pathogens. They're passive aggressive. Instead, they take control and direct the immune responses taken. The T cell receptors of helper T cells recognize antigens bound to class II MHC molecules. Helper T cells have a weaker association with the MHC antigen complex than shown by the killer T cells, meaning that many receptors on the helper T cell must be bound by an antigen in order to actually activate the cell, while single engagement in a killer T cell is sufficient to activate the cell. Activation of a helper T cell also requires longer duration of engagement. Activation of a helper T cell triggers the release of cytokines, which influence the activity of many other immune cells, such as macrophage and killer T cells. In addition, helper T cell activation triggers stimulatory signals which activate antibody-producing B cells. As seen in this animation, the helper T cells are effective in guiding the immune responses of the body. B lymphocytes identify a pathogen when antibodies bind to the antigens. This attracts a matching helper T cell, which activates a B cell. You can't have the TB without the T or the B. As the B cell divides, it secretes millions of copies of its antibody. These circulate through the body and bind to pathogens expressing the proper antigen and mark them for destruction by complement activation over uptake and destruction by phagocytes. By binding to bacterial toxins or the receptors used by bacteria and viruses to infect cells, it is also possible for antibodies to neutralize threats directly. Here, you can see an antibody binding to an antigen. Holy cow. When T and B cells replicate, some of the offspring become memory cells. They remember things. Each of these cells remembers a specific pathogen throughout the lifetime of the animal and can mount a strong response should there be an encounter with that pathogen again. This is adaptive because it shows the immune system's tendency to prepare for the future in the present. And that's all I have to say.
Thank you. Now, class, it is time for part 4, Life Without the Immune System. Oh, here, I know what it is. Living is easy enough with the immune system. Aside from a few cases of illnesses, we are kept safe behind a formidable barrier of immune defenses and responses. However, things can go wrong. And when they do, well, bad things can happen. Depending on the level of the immunodeficiency, things can be manageable or deadly. Should the immune system disappear completely, any small pathogen would be able to wreak havoc with our bodies and eventually kill us. Something as seemingly harmless as a common cold would be deadly. The immune system never goes away completely, but some of the deficiencies outlined below make it appear to do so. If a person develops an autoimmune disease, their body is no longer able to distinguish between pathogenic cells and self cells. This results in an overreactive response that can often be detrimental to the body, as well as the pathogens. Under normal conditions, there is a limited amount of reaction between immune responses and self cells. Even if a response harms some self cells, this is often considered healthy. The disease only comes after the immune system has mounted a response against its own cells and tissues. Obviously, it is a serious problem if the body is assaulting its own systems. The pathogens may not be killing someone suffering from autoimmunity, but their own defenses are. Here's an example of one of these very scary conditions. Severe Combined Immunodeficiency, or SCID, also known as the Bubble Boy Syndrome, Adam Sandler, in which the adaptive immune system is crippled due to a defect in one of several possible genes. Victims are extremely vulnerable to disease and cannot build up any form of immunity to any disease. The disease has been successfully used in treating, and even curing the disease. David Vedder, the original Bubble Boy, underwent such a procedure but was killed by a virus present in the new bone marrow. Since then, the techniques used have improved, and babies 3 months old or less stand a high chance of survival if they undergo a bone marrow transplant. Another method of treatment is gene therapy, which has currently cured 17 cases of SCID. Yay! The most infamous immunodeficiency is the human immunodeficiency virus, or HIV. Don't test positive for this one. This virus has reached pandemic levels, and to date there is no cure. The virus attacks a variety of immune cells, helper T cells and macrophages being the most prominent. The virus mutates and replicates quickly. This makes it one deadly force and one to be reckoned with. When the helper T cell count drops below a critical level, HIV becomes the far more sinister AIDS, acquired immunodeficiency syndrome. While HIV and AIDS are treatable, the treatment requires a large sum of money and cannot cure the disease. Basketball star Irvin "Magic" Johnson Jr. announced in 1991 that he had tested positive for HIV. Johnson has been alive and well since then and is devoting a large portion of his life and funds to researching possible cures for the disease, as well as advocating safe sex practices. Good guy. Good guy.
Alright, class. Well, it's time for the final part. Part 5. The conclusion.
You are under attack. As you listen to this conclusion, millions of possible killers are attempting to beat the defenses your body has developed. While this may seem grim, I urge you, do not worry. There's little chance that anything can happen to you with such a powerful set of defenses set up. So sit back, relax, and let your immune system do its duty. This is Sean, signing off.